So, in the previous class we had said the ice cream, what it is made of and what the constituents do, what is the role of the constituents. So, in this dairy and food process and products technology lecture number 54, let us look into how it is made, right, what is the process by which ice cream is manufactured. You see, I have given a flow chart in the way that solid raw material, whatever it comes, right, we have said in the constituents that you have sugar, you have butter, you have stabilizer, emulsifier, then solid not fat. So, all these solids are there, all the materials are coming, and then milk. In many cases people do directly use milk, or that depends on the manufacturer whether they will substitute water with milk, or they will take water from the milk, or they will add externally water and make the composition. That is entirely the manufacturer's right, or they select. But whatever it comes the solid raw materials, it comes, right. So, this solid raw material comes and then they are mixed with the liquid and solid. So, this is mixed and pasteurized. So, after mixing and pasteurization, it goes to homogenization, that is the process flow chart. It goes to homogenization of the ice cream mix. This is called ice cream mix. Here whatever is being going is called ice cream mix. Right. So, this ice cream mix is then homogenized, and then it from homogenization goes to chilling. After chilling, it is aged or called aging. Then it goes to flavor and color addition. Then it is taken to the freezer. So, when it is getting frozen, so at the before it is coming out, these fruits and nuts are added in that softy or soft ice cream, and then it is going to for bulk packaging. So, maybe small cups like that, if this is a 50 ml cup, like that, say 12 or 24, 50 ml cup, 24 numbers are packed in a container in a paper pack, and then it goes for hardening, right. So, bulk packaging it is there, and then it goes for hardening, and after hardening it goes to the cold room. From the cold room goes to dispatch and to the market, right. But in all the cases, there is a quality control which controls all the quality at every stage, right from the raw material or milk, then mixing and pasteurization when it is over or not, then homogenization, that is proper or not, then chill for definite period, that is done or not, then aging, aging is for a definite period, chilling at a definite temperature, aging for a definite period, whether that is done, then flavors and colors are added, then fruits and nuts come into the freezer before it is exiting, then packaging should be. So, every stage quality control is being considered, and this quality control is controlling the quality of the product, right. Now, how then, what are the parameters which is involved in this process flow chart? This is a typical ice cream making industry where layout I have given, right. So, do not look at these because these are some, but this was, it is no longer there. I used to work there, that is why I could make it, right. So, here you see the primary things are that your product is coming, right, your product is coming yeah, it is coming, and then it is going for here, right. It is going for your mixing and mixing and after mixing it is going for your pasteurization and then homogenization, and everywhere there is a quality control which is coming in, and these ice cream lollies are being made, the freezers are there, right, and cold storage hardening room, this is the hardening room, cold storage, they are side by side, right, and this is the outlet bay where the loading unloading are being done, right. So, this is the quality QCR room, quality control room, where it is being done. This is the aging vats, right, and this is a brine tank where your ice cream lollies are being made, right. This is the cream, then pasteurization, homogenization, they are being done. Then could be whatever heating boiler is coming through, and these are the different freezers which are used. Okay. So, this is a layout for the entire thing. Then how it looks like under microscope? Under microscope it looks like this, where A is the ice crystals, these are ice crystals, right. A like this, these are ice crystals, right. Then B is air cells, these are air cells, right. These are air cells, and then C is unfrozen material. Whatever is not frozen, that part is C. This is that C is the unfrozen material, right. And another thing which you need to know is that let me take it temporarily to this side, because temporarily I am taking it. Okay. So, here you see that the unfrozen material is C, and average distance between ice crystals or ice crystals and air cells is around 6 to 8 microns between ice crystals and ice crystals and air cells, right. Ice crystals is A. So, that is this one and this one or this one, the average distance is around 6 to 8 microns, and also between this A to B or say A to B, right, they are 6 to 8 microns. Average distance between air cells is around 100 to 150 microns. Between air cells where average size is around 110 to 185 microns, this air size, whereas ice crystal size is around 45 to 55 microns, right. So, air cells distance, that is B to B, this is around 150 to 180, 100 to 150 micron size. So, this is under microscope. If you look at it, looks like that, right. So, let us put back it to its original place. So, if we look at this, Yeah. So, if we look at this, then ice cream, how it is made up, the process is like this, that you are pasteurizing whatever be the container size, 900 liter typically, in steam jacketed vessels, 70 degree centigrade for 30 minutes. Then homogenization is done around 2000 liters per hour in two stages. One stage is 2500 psig and the second stage is 500 psig, and fat size globule is around 2 micron. Then chilling, this is done by counter current plate heat exchanger through ethylene glycol as the refrigerant and ethylene glycol water mixture, and the capacity could be 2000 liters per hour, and it is chilled to 4 degrees centigrade. Then aging is done with freon fuel refrigeration in vat, big containers with 500 liters, and this is done for 4 hours. Then freezing is done, usually the commercial freezer sizes are between 300 to 700 liters per hour, and the refrigeration could be ammonia or could be freon fuel depending on what you have. And the outlet temperature of ice cream is -5. So, at -5 degree centigrade this becomes soft, which you buy from the market as softy, that temperature is around -4, -4, 5 like that, right. It becomes soft, it is softy and flowable. Unless it has flowability, it will not go to the other side of the freezer, right. So, you just imagine that in your household deep freezer you have kept water, it got ice. So, you cannot take it unless you force it, right. In this case, ice cream is coming out from the freezer continuously, because as you see it is around 300 to 700 liters per hour capacity. So, that means it is continuously flowing, right. So, it should have flowability. That is possible if the temperature is not lower than -5. So, coming out at -5, and initial freezing point of ice cream generally is around -2.5. So, -2.5 it started freezing, and maybe some portion has frozen 5%, -5 degrees centigrade, you have taken out the ice cream, and this soft ice cream is then packed and then kept in hardening room for solidifying, and then to the cold room. That is what it is done. So, filling that can be done manually or automatically. Those cups which you get, they are automatically filled in the containers, or the big packets, like from where scoops are being made in some functions or in some gatherings. So, ice cream scoop is being made, that is from the gallon packs or 4 liter packs, from there it is coming, right. Then hardening, this hardening is done in hardening room with either ammonia or freon, and the temperature is around -40 degrees centigrade, right, and the product temperature could be somewhere around -30 degrees centigrade, and it takes around 2 to 8 hours. Obviously, a cup of 50 ml will take less time than a packet of 4 liters, right. 4 liter takes around 8 to 10 hours for hardening, whereas a small cup 50 ml may take half an hour, 1 hour, 2 hours at the most, depending on the environment temperature. This will come also in detail, because not only this will help us to know about the ice cream manufacturing, but also with associated refrigeration, that also will be a little bit covered. Then the cold room is at minus 25 with ammonia, and then it is going to dispatch with insulated shipper, dry pad, pad van, mechanical refrigerated or refrigerated van or polar stream. All these are used for dispatching the product from the production point to different places or agencies or storages, right. In big cities, your production could be at one place and manufacture could be at one place and consumption could be at another place. It is so big a distance that here if it is produced, here if it is to be consumed, maybe in between one cold room is there. So, it comes here, stays there for days together, and maybe depending on requirement goes to there, right. So, this way the ice cream is manufactured in this is the process flow chart and the parameters which are involved in the production, right. Now, let us look into how the ice cream industry they are using. This is of course small typical, this is for the laboratory use our thing. So, this is a pasteurizer, right, and then it goes to homogenizer. So, this is a pasteurizer with these are the plate, this is the plate heat exchanger. So, with the controls and other things. So, all pipelines, this is the commercial one. So, pasteurizers are using for pasteurizations, plate heat exchangers. Then it goes to homogenizer. So, this is a typical homogenizer, right, APV make. So, that homogenizer is homogenizing the fat to around say 2 micron, and this is a 2 stage. So, one stage is around 2500 psig and the second stage is around 500 psig, right. Then from there it goes to the freezer. This is a typical view for ice cream freezer, right. And this typical view is that it includes everything. Number one, this is the part where the refrigeration takes place, right. That refrigeration part is all along like this, and this is the part where the feed of the ice cream mix is happening, as well the air is being fed, and this is the ice cream freezer, the heart of the ice cream industry, ice cream freezer, right. What it is doing? So, if it is ammonia or freon 12 whatever, that is under this section, right. So, the liquid either ammonia or freon, that is then coming to the ice cream freezer, right. This is at the outlet, you see it is insulated, right, like this is insulated, and the liquid is coming here, and this is called boil off technology, right. Liquid ammonia or freon that is coming here and getting boiled off, right, giving the latent heat, right, delta H, giving the latent heat to the product, right. Sensibility, it is not so much available, because the moment this liquid is vaporized, that vapor comes out and comes back and again puts back into the cycle, right. So, that is the vapor which is coming in out. So, this refrigerant is coming here. the refrigerant is going out from there. Then the other two thing is the mix and the pump, mix and the air. Now, both mix and air, this is the dual pump, right. In one case this is mix is getting in another case that air that is getting in, right. So, both air and the ice cream mix, they are going in and put into the system, right, and this system is this. So, this is the wall, inner wall of the ice cream, and ice cream wall, if you have seen it, it is like a mirror or more than a mirror, right. So, here you need to know a little about the freezing, right, because freezing, if you see that the faster the freezing, the quicker the freezing, the ice crystal sizes are smaller. The smaller the ice crystal sizes, less is the space required for the volume expanded. We know that 9 cc of water, when it is getting converted into ice, 11 cc of the ice is formed. So, that is called 9-11. This 9-11 conversion, that is less water volume with more ice volume. So, that ice volume has to be accommodated. Now, this 9 to 11, if it is 9 to 11, then only 2. If it is 900 to 1100, then it is 200, right. But if it is 0.09 to 0.1, then it is very small. Even if it is even smaller, 0.0009 to 0.01, then it is even smaller. So, that means the quicker the freezing, the smaller will be the ice crystal size, and the smaller the ice crystal size, the better for the quality of the product, right. And if that is there, that is being done in this section, that is the ice cream manufacturing section, right. So, the product or this mix along with the air is going in. So, here this mix was at 4 degrees centigrade after aging. So, at 4 degrees centigrade, this mix is getting pumped entering into the inlet of the ice cream freezer. Now, this 4 degrees centigrade, when it is coming out of this is at -5 degrees centigrade, right, and it is a continuous, as we said, 300 liters per hour say or 700 liters per hour. That means, at every hour 700 liters ice cream is being formed. So, when it is entering here at 4 degree, by the time it comes out from the exit, it is at -5, a semi solid or flowable composition. So, that -5 degree, this is being done, this is called the scrap surface heat exchanger or SSHE, scrap surface heat exchanger. So, this is generally written as SCRAPPED, scrapped surface heat exchanger, right. What actually is happening, if this is the wall of the ice cream barrel, that is called barrel, this is called barrel. So, in this barrel, this outer side is with the refrigerant, right. This outer side is with the refrigerant, which is at say -30, minus 28 depending on what refrigerant you are using. It is giving at its latent heat delta H to this wall, right, and this wall, this ice cream, say we talk about one molecule. I cannot make the color another. Okay, let me try whether it is making. Yeah. So if this is a ice cream mixed molecule, so then that comes here at the entry, then it is going here to the wall, getting it solidified, because then it will be solidified. Then the scraper blade, which is this one, there is the blade here, the scraper blade that is scraping off, that is scraping it off like this, right. If this is the blade, so it is going like this and scraping it off like that, right. This scraping is done by the scraper blade the moment inside ice cream is formed. So that getting then mixed with the interior, and from this 4 degree here it has become say minus 0.1 degree, and then gradually it is mixing and getting frozen like that and moving, and at the end when it is coming here it is at minus 5 degree centigrade, right. So, minus 5 degree centigrade it is coming the way it is mixing with the inside of the blade, inside of the barrel, where it is getting frozen, getting it scraped off, get mixed with the remaining ice cream liquid, whose temperature is gradually going down from plus 4 degree to minus 5 degree. So, plus 4 to minus 5, this entire length of the ice cream freezer is taking place. So, this is what that ice cream, this length, within this length, this is 4 degrees centigrade and this is at minus 5 degrees centigrade, that is coming out, right. Now, what is happening after that? This ice cream now here, which is flowable at minus 5 degree centigrade, this is kept, this is being held in containers like cups, maybe 50 ml or maybe 100 ml bigger cups, right, 100 ml. They are filled in, say, in circular, this kind of your things are there, where cups are being made, and some mechanism by which when it is coming here, that is getting shifted to the next, and this way it is moving, right. And when all are it is in a line, and maybe from here it goes to a chain sprocket line, where your ice cream, this cup lids are being put, right. And then maybe if it is 100 ml, then 12 with numbers, it is packed in a paper container, or if it is 50 ml, then it is packed in a 24 numbers container, paper packet, right, and that is kept in the hardening room for hardening, or maybe from here that entire thing comes into your container, which is 1 liter pack called party pack, 1 liter pack, that is called party pack, or generally not in kg, but liter, 1 liter party pack, or maybe 4 liter called gallon pack, right, 4 liter called gallon pack, because 1 gallon typically is 3.75 or something like that, but since in our country, it is not gallon, it is liter. So, it is 4 liter packs, where big packets of 4 liters are filled automatically. And then these all are taken to that hardening room, which we had said the hardening room is say minus 35 to minus 40 degrees centigrade, right. So, minus 35 to minus 40 degrees centigrade, these are kept for 2 to 10 hours depending on size, shape, etc. Right. So, after this is hardened, then it goes to the cold room, and this cold room it is kept maybe for 1 day, maybe for 10 days, maybe for depending on the sale of the product, right. And then this is dispersed through different medium. So, that we will discuss in the next class, that how the frozen foods are being distributed, in what way they are getting distributed, what is the mechanism, how they are surviving. These things we will discuss in the next class, because today we are running out of time. Hopefully, you have understood the manufacturing process and why all the steps are required, what is their purpose. This we have tried to give you in detail. Okay? Thank you.